Let us discuss some of the steps that you would logically wish to do if you were to analyze a large dataset. This being in general and not only applicable to the final project, although also yes, it would be applicable to this. Our first step should be to try to understand the question of what it is that the client wants you to find out. If you do not understand what they wish to answer, you may come to an illogical decision after you have done your model. When you feel like you understand the question that you are trying to answer, then you should ask the client what they understand about those relationships. And there may be some relationships which they think are more important. And remember, the good of the many always outweighs the needs of the few. So if you know what you should have, that will help you to determine should it be a quadratic or a log. In this particular class, you may notice that you don't get to talk to the client. And so this step you are forcibly not allowed to do. But you can still put the data into R. And in some cases, this can be very difficult. Because the final project follows similar data sets we have used in this class, this step should not be as difficult as looking for errors. And you can rest assured there will be errors in the data set. That is only logical. It may take you a while to find them. Some of the most logical places for you to find errors would be by plotting pictures and see where there is a data point which is clearly outside the range of what the other data points are allowed to do. In real life, sometimes errors can be more subtle, and that is one thing you would want to ask the client about. What values are reasonable? Would you say that $100 is reasonable or unreasonable? That might depend on the scenario. In this class, since you cannot revisit the client about the errors, you will notice they are very extreme and, in my opinion, rather obvious. And since my opinion is so logical, that of course means that they are. Once you have fixed the errors, then your plots will look reasonable and have some valuable information for you. You may notice that so far we have not actually done any statistics. We have only understood what we're doing, fixed the errors in the data set, and put the errors into the computer and looked at some pictures of the data. No statistics yet. And this step often is where you will spend half your time, which it's a good thing that you will live long and you will prosper if you do these things well. After you finally have a good data set that you have looked at, that is when you will finally make a model. And that will probably be a very classic LM statement with the response based off all the other variables, quite simply. The chance that that is the final form of the model is not very good, which is why you would look at those residuals to see, would it be logical to add a quadratic or a cubic, or are there indications of a log? Perhaps you will see similar patterns in two variables and think that perhaps an interaction would be something that you should try. Those residuals will give you a clue as to what you can do to improve the model. Improve the model does not mean that you have the final form, but simply that there will be one variable which you can do something to help it predict the response better, which then you will go back to your model, back to the residuals, and improve again. Model, residuals, improve. Model, residuals, improve. And back and forth between these steps is often you will spend a lot of your time doing, which is why you will live long as you do this, and you will prosper when you find what model you think is appropriate. There may be more than one appropriate model, and you will make choices. If the x squared term is significant and x is not, will you leave it in the model or not? That decision is something that some people might disagree. You do not have to agree with me, but you do have to show me why you selected that model. Part of this model selection includes eliminating variables that should not be in your model because they do not improve your prediction. When you finally decide that you have the most logical model, you should be able to justify why you believe that it is better than any other model, even if it is simply because these are the rules that you like to do statistics by, and this model is the correct model following those rules. Having finished your model, you are now ready to return to the client and say, here's what I thought you wanted to know. Here is what my analysis has shown. Is this the question that you were trying to answer? And is this a satisfactory answer based on what the data is able to tell us? Many times the client will say, yes, you have proven yourself to be most logical. Sometimes they will say, there is some additional part that I feel like I miscommunicated. And that might send you back here where you will rework with the model, trying to find the answers that the client wants you to do. In this class, we do not have a client, but it is a good idea for you to reread what the final project asked you to do and to ask yourself, am I ready to answer this question? If you are, then you might be ready to start interpreting those coefficients. If you have simple linear terms, those should be very straightforward to interpret, using the same kinds of definitions that we've talked about since the intro courses. As x increases, y increases. However, some variables might have complex curvature, interactions, or other things where a graph would be the best way to do it. A log transformation does count as easy, you can interpret it, but a numerical interaction does count as hard, a graph is going to help you. By the time you are done, everything in your model should have been explained, either easy with some explanations or as a picture, also including explanations of what that picture is showing. Explaining all the pieces of your model also includes explaining what pieces were left out, which is a simple explanation. This variable did not help us to predict the response, or this variable was not needed because other variables were doing the job. But the client deserves to know that all the pieces were examined. You are now complete with the analysis. It is time to turn to the writing. The first part is going to be the introduction. Some people feel like an introduction should be done last, and that is okay if that is your style. But an introduction should be interesting, to grab the reader's attention, to tell them how incredibly logical and exciting your report is. Whatever you do, do not make it sound like a Vulcan has written it. You are then ready to talk about the model creation. These loops that you went through here, you do not need to explain every step, but in the end, why did you feel like a log or a cubic or an interaction was valuable? You should be able to say what it was through this looping process that made you eventually decide to have the model that you used. And now your report can include these details on either the easy variables or the hard ones, which variables were not included, so that you can answer the question that the client wanted you to do. This is perhaps the most important step, the step that everything else was simply here to support. Are you able to explain how to maximize enemy casualties or minimize civilian casualties, as it asks for in the final project? Can you finally answer what it is they want to know? Forget the math, forget the equations, forget the forms. Here's how you do it. And then a conclusion. A conclusion will summarize everything that you have seen before, the most important and exciting variables, and a brief explanation of the answer given before, along with some ideas of here's where we are going to go next, which makes your report seem very exciting and not at all droning Vulcan style. Usually after this step, you would meet with the client to show him what answers or her what answers you were able to discover. You would go through the report, the model selection, and most importantly, here's the answer to the question, and you would be able to talk to them about what pieces they did or did not understand. In this class, we do not have a client. You do not need to do a presentation, but you do get graded on how well it went. But you do not need to worry as long as you remember, oh, that's my lunch.